This video is brought to you by mywayteaching.com.
In this part, let us see what is this acceleration. We know the velocity of an object changes during its course of motion, isn't it? How to describe this? Should it be described as the rate of change in velocity with the distance or with this time? Do you have any idea? Okay, this was a problem even in Galileo's time. It was first thought that this change could be described by the rate of change of velocity with distance. But through his studies of motion of freely falling objects and motion of objects on an inclined plane, Galileo concluded that the rate of change of velocity with the time is a constant of motion for all objects in free fall. On the other hand, the change in velocity with the distance is not constant. It decreases with increase in distance of fall. Okay, if we increase the distance, that change will decrease. Change in velocity will decrease if we consider with respect to distance. So, we describe acceleration as rate of change of velocity with the time. Okay. Acceleration is nothing but rate of change of velocity. With the time. Okay. The average acceleration a bar, the average acceleration a bar over a time is defined as the change of velocity divided by the time interval. So this average acceleration we can say it as a change in velocity. Change is nothing but v2 by v1 divided by the time interval, that is given by t2 by minus t1. Okay, so we can call this v2 minus v1 as delta v and t2 minus t1 as delta t. Okay, so where v2 and v1 are the instantaneous velocities. Okay, what are this v2 and v1? They are instantaneous velocities. Or simply velocities at the time t2 and t1. It is the average change of velocity per unit time. This average acceleration is average change of velocity per unit time. Okay, and the SI unit for this acceleration is given by meter per second square. Okay, the SI unit of velocity is meter per second and this time is again second. So it gives meter per second square. On a plot of velocity versus time, the average acceleration is the slope of the straight line connecting the points corresponding to v2, t2 and v1, t1. Okay, on an if we consider the graph, then the slope of the line which connects the points like v2 v2 comma t2 and v1 comma t1, and that slope gives the average acceleration. Okay, the average acceleration for velocity time graph is shown in this figure. You can see this is a velocity time graph. Okay, and for different the acceleration time graph for, so this the acceleration as a function of time for motion for the figure that we just saw previously, that velocity. Okay, the figure of the car that we saw, isn't it? For that, we are considering this acceleration. For this position time graph of a car, we are drawing this acceleration as a function of time for motion. So here we can consider the average acceleration between the time intervals, that is 0 second to 10 second, okay, and 10 second to 18 second, 18 second to 20 second, okay. So we are considering the average acceleration for all these three cases. For the first case, acceleration is given by v2 minus v1 by t2 minus t1. So if we want, this is an acceleration graph, but we can write this average acceleration by considering the velocity time graph, okay. So for the first case, 0 second to 10 seconds, considering this graph, the average acceleration is given by, that is v2, that is at 10 second, you can see for 10 seconds, if I see, we'll get approximately 24, isn't it? And similarly for 0 second, what is the velocity? It is 0. So we can write v2 minus v1 as 24 minus 0 by 10 minus 0, and it is given by 2.4 meter per second square, okay. And similarly for the second case, that is 10 seconds to 18 seconds, we can consider average acceleration at 18 second. It is given by, yeah, it is 24, because it is constant here, you can see. If you consider at 18 seconds or at 10 seconds, it comes in this particular constant line. So here it is, the acceleration is given by 24 minus 24 by 18 minus 10, that is given by 0 meter per second square, okay. Similarly, the third case we can write, that is 18 seconds to 20 seconds, that is given by, at 20 second again it is 0, and at 18 it is 24. You can write it as 20 minus 18. The acceleration is negative, that is minus 12 meter per second square, okay. This is about the instantaneous acceleration is defined in the same way as instantaneous velocity. So it is given by, the instantaneous acceleration is given by limit of delta v by delta t as delta t tends to 0. We can write it using differential calculus as dv by dt. So the acceleration at an instant is the slope of the tangent to the v by t curve at that instant. This is an example of vt curve, isn't it? And for this vt curve, we can obtain the at curve like this. Okay. We see that the acceleration is non-uniform over the period 0 to 10 seconds. Okay. It is 0 between 10 seconds to 18 seconds, and it is constant. The acceleration is constant from 18 to 20 second. You can see here, here it is non-uniform, here it is constant, and here it is 0, and here it is constant. When the acceleration is uniform, obviously it equals the average acceleration over that period. Since velocity is a quantity which is having both magnitude and direction, a change in velocity may involve either or both of these factors. Okay, if velocity changes means that change can be both direction and magnitude, or it may involve any one also. Therefore, acceleration may result from a change in speed, which means change in magnitude, or a change in direction, or change in both. Like velocity, this acceleration can be positive, as just now in the previous example we saw. We got both positive values also, negative values also. It can be 0 also, isn't it? And for this acceleration, we can show different graphs. That graphs are called as position time graph for motion with positive acceleration, negative acceleration, and zero acceleration. Okay, this graph curves which are upward, they represent positive acceleration. Okay, if the curves are upward, they represent positive acceleration. If they are downward, then they represent negative acceleration. If it is a straight line, then they represent zero acceleration. Okay. The average acceleration equals the constant value of acceleration during the interval. If the velocity of an object is v naught at t is equal to 0, okay, and if the velocity of an object v is v at time t, then we can write this acceleration as v minus v naught divided by t minus 0. Or else we can also write by simplifying this equation, v is equal to v naught plus at. Okay, this is a very important formula for finding the velocity.